Imagine you're aboard a spacecraft approaching Jupiter. At a distance, it looks almost peaceful. Swirling bands of cream and orange, that famous red spot. Storms larger than the Earth. It's beautiful. But as you get closer, something feels wrong. The radiation alarm starts screaming. Your instruments begin to malfunction. And then you realize you're not approaching a planet. You're approaching a monster. And by the end of this video, you'll understand why even NASA sends spacecraft to Jupiter knowing they probably won't survive. Now, everyone knows Jupiter is big, but the word big doesn't really capture the scale we're dealing with. Imagine lining up Earth next to Jupiter. Now add another Earth and another, and keep going. You could fit more than 1,300 Earths inside Jupiter. And that's not an exaggeration. If Jupiter were hollow, which thankfully it isn't, you could literally pack over 1,000 Earth-sized planets into its volume. But size alone isn't what makes Jupiter intimidating. It's the mass. Jupiter contains more than 2.5 times the mass of every other planet in the solar system combined. Think about that for a second. Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune. Every moon, every asteroid, every dwarf planet. Add them all together. Jupiter still outweighs them by a lot. And here's where things start to get even stranger, because Jupiter sits on the edge of something incredible, something that almost changed the entire history of our solar system. You see, Jupiter is dangerously close to becoming a star, not metaphorically, literally. When stars form, they ignite nuclear fusion once they reach a critical mass. Hydrogen atoms begin smashing together under immense pressure, releasing enormous amounts of energy. That's what powers the Sun. Jupiter almost reached that threshold. If it had been about 80 times more massive when it formed, fusion would have started in its core. Instead of one sun, our solar system would have had two. A binary star system. And if that had happened, Earth might never have existed at all. No stable orbit, no calm, habitable zone. Possibly no life. But Jupiter stopped just short of that boundary. Not massive enough to ignite like a star, yet far too massive to behave like a normal planet. So instead, what we ended up with is something arguably more unsettling. A giant sphere of gas with crushing pressures, monstrous storms, and an interior so extreme that the laws of physics begin to behave differently. And this is where the real story begins. Because once you descend into Jupiter's atmosphere, things go downhill very quickly. From far away, Jupiter's surface looks like weather patterns, cloud bands, storm systems, swirling winds. But calling it weather is almost misleading. What you're seeing is chaos on a planetary scale. Take the most famous example, the Great Red Spot. You've probably seen pictures of it before, a giant red storm that has been raging for centuries. Astronomers first recorded it more than 400 years ago, and it may have existed long before that. Think about that. A single storm that has lasted longer than the entire history of modern science. And the scale of it is almost impossible to grasp. The Great Red Spot is large enough to swallow Earth whole, not just cover it, engulf it. Winds along its edges exceed 400 kilometers per hour, and by Jupiter's standards, that's actually considered moderate. Elsewhere in the atmosphere, jet streams rip across the planet at over 600 kilometers per hour. Entire walls of gas racing around the planet faster than hurricane winds on Earth. But the storms aren't the most terrifying part of Jupiter. Not even close. Because storms, at least in theory, have boundaries. Jupiter doesn't. There is no surface. If you tried to land there, you wouldn't hit ground. You would simply keep falling. Deeper and deeper into the atmosphere as the pressure builds, and builds, and builds. Eventually, the pressure becomes so extreme that the very nature of matter begins to change. Hydrogen, the simplest element in the universe, behaves very differently under that kind of compression. Here on Earth, hydrogen is a gas. But inside Jupiter, the pressure forces hydrogen atoms so close together that electrons begin moving freely between them. The result? Liquid metallic hydrogen, a substance so strange that it behaves like both a liquid and a metal at the same time. It can conduct electricity, it flows like fluid, and it's likely responsible for something that makes Jupiter far more dangerous than its storms: its magnetic field. Earth has a magnetic field too. It's the reason compasses work. It protects us from charged particles streaming from the sun. Without it, solar radiation would gradually strip away our atmosphere. Life on Earth might never have survived, but Jupiter's magnetic field makes Earth's look tiny. Jupiter's is roughly 20,000 times stronger. To visualize that, imagine if we could somehow see Jupiter's magnetic field with our eyes. It would appear enormous in the sky, far larger than the full moon, and it wouldn't stop near the planet. It stretches millions of kilometers into space. In fact, Jupiter's magnetosphere is the largest structure in the entire solar system, larger than the Sun itself. But unlike Earth's magnetic field, Jupiter's doesn't simply deflect radiation, it traps it. Charged particles from the solar wind get captured and accelerated to incredible speeds, near light speed in some cases. The result is a series of radiation belts surrounding Jupiter, and these belts are deadly. An unprotected human spacecraft passing through them would expose its crew to lethal radiation doses within minutes. Not hours, minutes. This isn't theoretical either. We've seen what the radiation does to spacecraft. When NASA launched the Juno probe to study Jupiter, engineers knew it would face one of the harshest radiation environments ever encountered. So they built something unusual into the spacecraft: a radiation vault, essentially a titanium box designed to shield its electronics. The vault weighs about 200 kilograms, and even with that protection, Juno still has to be extremely careful. It can't remain close to Jupiter for long. Instead, it follows a stretched, looping orbit. It dives toward Jupiter to collect data for a few hours, then escapes back out to safer distances before the radiation becomes overwhelming. Even then, the radiation is slowly degrading the spacecraft. And Juno is one of the most hardened probes we've ever built. Earlier missions didn't fare much better. The Galileo spacecraft spent years studying Jupiter and its moons. But by the time its mission ended, its systems had absorbed radiation equivalent to tens of millions of dental X-rays. Eventually, NASA deliberately sent it plunging into Jupiter's atmosphere, partly to avoid contaminating Jupiter's moons, and partly because the radiation had already pushed the spacecraft to its limits. But Jupiter's dangers don't stop at radiation, because Jupiter doesn't just dominate its immediate surroundings. It influences the entire solar system. Its gravity is enormous, so enormous that it may have shaped the formation of the planets themselves. Scientists believe that early in the solar system's history, Jupiter actually migrated inward toward the Sun, much closer than it is today. There's a theory called the Grand Tack hypothesis. According to this idea, Jupiter drifted inward until it reached roughly the distance where Mars now orbits. Then Saturn formed, and Saturn's gravity pulled Jupiter back outward again. But during that migration, Jupiter wreaked havoc on the early solar system. It scattered massive amounts of material, destroyed forming planets, and prevented Mars from ever growing as large as Earth. In fact, the asteroid belt may exist because Jupiter wouldn't allow those objects to merge into a planet. Its gravity constantly stirred them up. breaking apart early building blocks before they could come together. Even today, Jupiter continues acting like a gravitational gatekeeper. Comets drifting in from the outer solar system. Rogue asteroids crossing planetary orbits. Many of them end up interacting with Jupiter. Sometimes it captures them. Sometimes it flings them away entirely. And sometimes it destroys them. We actually witnessed this happen in 1994. A comet called Shoemaker-Levy 9 was captured by Jupiter's gravity. As it approached the planet, tidal forces tore the comet apart into more than 20 fragments. Then, over the course of several days, those fragments slammed into Jupiter one by one. Each impact exploded with the force of millions of nuclear bombs. Dark scars larger than Earth appeared in Jupiter's atmosphere, visible even from telescopes on Earth. If just one of those fragments had struck our planet, the result could have been catastrophic, possibly even an extinction-level event. So, in some ways, Jupiter acts like a cosmic shield. But in other cases, its gravity can also redirect objects toward the inner solar system. In other words, sometimes Jupiter protects us, and sometimes it makes things worse. But Jupiter's reach doesn't end with asteroids and comets. It also controls the fate of dozens of moons trapped in its gravitational grip. Some of those moons may even contain oceans beneath their icy surfaces. Europa, for example, is believed to hide a vast liquid ocean beneath kilometers of ice, a place where alien life might exist. But even there, Jupiter's presence is impossible to ignore. Europa sits inside Jupiter's radiation belts. The radiation levels on its surface are lethal. Any future lander will need heavy shielding just to survive. And then there's Io, the innermost large moon of Jupiter. Io is the most volcanically active body in the entire solar system. Not because it has a molten core like Earth, but because Jupiter is constantly pulling on it, stretching it, squeezing it, kneading it like dough. These tidal forces heat Io's interior until volcanoes erupt across its surface almost constantly. Entire landscapes are reshaped in a matter of years. Even Ganymede, the largest moon in the solar system, struggles against Jupiter's influence. It actually has its own magnetic field, the only moon known to have one. But even that isn't enough to fully protect it from Jupiter's radiation environment. So when you step back and look at the full picture, something becomes clear. Jupiter isn't dangerous in just one way. It's dangerous in every way at once. Its storms rage endlessly. Its gravity traps and crushes. Its radiation belts kill electronics and living tissue alike. Its magnetic field accelerates particles to unimaginable energies, and its gravitational reach extends across the solar system. Every spacecraft we send there operates on borrowed time, yet we keep going back. Because Jupiter is also one of the most important laboratories in planetary science. The secrets hidden inside that enormous planet could tell us how gas giants form across the universe, how solar systems evolve, and maybe even how life might survive in extreme environments. The Juno mission, which has been orbiting Jupiter since 2016, has already revealed surprising discoveries. Jupiter's core isn't solid like scientists once believed. Instead, it appears to be a fuzzy, diffuse region, possibly the remains of ancient planetary collisions. Its atmospheric storms extend far deeper into the planet than expected, hundreds of kilometers below the visible cloud tops, and its auroras, glowing lights at the poles, are far more powerful than anything seen on Earth. But even after decades of study, Jupiter remains profoundly alien. We will never walk on its surface, because it doesn't have one. We will never build floating cities in its atmosphere. The radiation and pressure make that impossible. Even robotic missions must carefully navigate around it, constantly avoiding the worst regions of radiation. Jupiter marks a boundary, a place humanity can study, but never truly inhabit. And perhaps that's the most humbling part of the story, because Jupiter has been here for 4.5 billion years. Long before life began on Earth, long before humans ever looked up at the night sky, and long after we're gone, Jupiter will still be there, its storms still spinning, its gravity still shaping the solar system, its radiation still flooding the space around it. So the next time you see Jupiter shining brightly in the night sky, remember this: you're not looking at a peaceful planet, you're looking at a colossal engine of chaos, a storm that has been raging since before the dinosaurs, a gravitational giant that has shaped the destiny of worlds. Jupiter isn't the king of the planets because it's noble. It's the king because nothing else survived long enough to challenge it, and we're only just beginning to understand it. If you enjoyed exploring the darker side of our solar system, consider subscribing, because out there beyond Jupiter, the universe only gets stranger.